Okay, so here we are at 314. It's called the rat race. So I'm going to encourage you to take some time to just read this problem in its entirety. Read it through, do the best you can to answer what you can. If you get stuck, then please come back and kind of start listening to the video for help or clarification. And if you kind of get some insight, go ahead and pause and keep exploring the problem a little bit on your own. Otherwise, feel free to continue watching in order to check your work. So we start off with the following. Ryan has a pet rat, Romeo, and he boasts it is the smartest rat in the county. Sammy overheard Ryan at the county fair claiming that Romeo could learn to run a particular maze and find the cheese at the end. I don't think Romeo is that smart, Sammy declares. I think the rat just chooses a random path through the maze. Ryan has built a maze with the floor plan shown at right. In addition, he has placed some cheese in an airtight container, so Romeo cannot smell the cheese in room A. Suppose that every time Romeo reaches a split in the maze, he is equally likely to choose any of the paths in front of him. Choose a method and calculate the probability that Romeo will end up in each room. In a sentence or two, explain why you chose the method you did. In essence, they're getting at tree diagram or area model. Now, the shape and this lesson title should hopefully make this an obvious choice. But if it isn't, consider the fact that as you take different choices, your options change. So it's not as simple as, hey, I've got these options for my first choice, I've got these options for my second, but if I go up to the left, I have several. If I go down the middle, I'm already done. So it kind of changes as we go. So we're going to take advantage of the tree diagram. I've already redrawn the picture. I've simplified it. So it's the same pathways. I just didn't draw all the lines going down the middle. I kind of just drew it as single steps, but we can still see room A and room B right there. Now in part B, calculate the probability that Romeo will end up in each room. Okay, so let's take advantage of that and come back to our tree diagram right here. So the information we have is that when Romeo gets to a fork, he's equally likely to take each leg. So when he's at this first decision right here, I see three options. So that means 1/3, 1/3, 1/3. Okay? Now, if he were to go to the top and end up at this fork, again, I see three options. So 1/3, 1/3, 1/3. So I filled those in with 1/3 as well. Now if he ends up down here at this fork, well now there's only two options. So I have a 1/2 and a 1/2. Okay? So with all that information in play, I can now multiply straight across to figure out the probability of ending up on any of these 1, 2, 3, 4, 5, 6 trails. So if I go across the top, 1/3 times 1/3 is 1/9. 1/3 times 1/3 is 1/9. 1/3 times 1/3, this is a 1/9. 1/3 down the middle, that's 1/3. 1/3 times a half is 1/6. And 1/3 times a half is 1/6. Now if you take these values of what would be our sample space, I could end up in room B, these three, or I could end up in room A, these three. If you add those up, they will add up to 1 because I have a 100% chance of ending up in either of these two rooms. May not be the same for both rooms, but in at least one of the rooms. So with that, let's find the probability of each. So the probability of ending up in room B means I need to add the three values for ending up in room B. So I have 1/9 plus 1/9 plus 1/6. So that gives me, let's see, 9 and 6 will make it 18. So 2/18 plus 2/18 plus 3/18, or 7/18. So that's my probability of ending up in room B. Now, probability of room A. I'm going to stop for a moment. If you haven't already, see if you remember an idea I talked about on Friday. It started with a C, and it can help us solve this problem really quickly. So go ahead and pause and talk this over with your group members for a second. Can you think of a shortcut to figure out the probability of ending up in room A? Okay, so here's the deal. I could add up my numbers for room A, 1/9 plus 1/3 plus 1/6, and that will work. So I can come over here and I can say 1/9 plus 1/3 plus 1/6 and do the exact same thing I just did for the probability of room B. But here's what I want you to consider. I either am in room A or I am in room B. There is no third option. So the probability of room A has to be 1 minus the probability of room B, or 1 minus 7 over 18, which means 11 over 18. This was what we referred to as the complement. If you have a probability where there are only 2 options and you know one of the probabilities, then it must be that the other is simply 1 minus the probability that you know. So we have our 2 probabilities, 7 out of 18, 11 out of 18. And it asks, after 100 attempts, Romeo has found the cheese 66 times. I'm actually going to grab a calculator real quick. Give me 1 second. I think I can make this work. So, oops. Okay, so coming back to this problem, I'm going to go ahead and write the decimal for both of these, because why not? So, calculator, let's go. So I need 7 divide 18. So this is 0.389. So our rule, remember, is always going to be 3 decimal places. That's going to make 11 over 18, 0.611, with rounding, obviously. So we go on to part B, and it says if the rat moves through the maze randomly out of 100 attempts, how many times would you expect Romeo to end up in room A? How many times would you expect him to end up in room B? Okay, well, if I take these ideas right here and multiply by 100, per 100 attempts, if it were truly random and he is not learning, then based off the percentages we just found, he should end up in room A about 61 times and room B about 39 times. Not perfectly, but it should be pretty close to that. So then we go to part C, and it says after 100 attempts, Romeo has found the cheese 66 times. See how smart Romeo is? Ryan asks. He clearly learned something and got better at the maze as he went along. Sammy isn't so sure. Do you think Romeo learned and improved his ability to return to the same room over time? Or could he just have been moving randomly? Discuss this question with your team, then write an argument that would convince Ryan or Sammy. I'm not going to give the answer to this one yet. I want you to talk this over with your team and you decide. Our prediction is 61 times if it was random chance. Romeo makes it 66 times. Too close? Not close enough? I want you to take a moment and discuss this, and then I will address it on Monday. So you decide. Is that good enough to say Romeo's getting smarter, or is it just random chance and this happened to be this one played out?